Okay, so notes. Week 27, part 2, we have more practice with trig identities. So, let's see this first example. It says prove or verify the identity, or sometimes it'll just say show that, meaning show that this is true. So we have something on the left-hand side, something on the right-hand side, and we're supposed to, the recommendation from in notes part 1 was always to either work with this side or work with this side, but use one or the other. So it looks like I started off to the right and did a common denominator. So the common denominator between these two is the multiplication of both. So this gets multiplied by 1 plus sine x, and this gets multiplied by 1 minus sine x, giving us this crazy stuff. Okay, yeah. And then I distributed the 1 and the minus 1, giving us this. Don't forget that minus times minus is plus. 1 minus 1 is 0, so we have 2 sine x up top. And then this, so, this was FOIL, so firsts, outers, inners, and lasts. And the middle terms are going to cancel out. If you don't believe me, you should multiply that out and try, but these two are going to cancel. So our firsts were this, and our lasts were this. And then from the most common, our most common identity, sine squared plus cosine squared equals 1. All right, this takes many forms, but this is one form of it, right? If we were to subtract sine x, sine squared x from both sides, we would learn that 1 minus sine squared x is cosine squared x. So again, most common trig identity right here, and it'll take this form as well, turning this into this. So where are we? We have, we combined these to get 2 sine x, and it's over cosine squared of x. So cosine squared of x is cosine x times cosine of x. And if we kind of line them up like this, we recognize that, hey, that's tangent, and that is secant. And this is what we're trying to do, is to verify, show, prove that this is equal to 2 tan x secant x, which we just did. Oh yeah. So these are going to seem challenging, at least at first. But you just have to kind of go for it and try stuff, and keep in, as you're working through, keep in mind, hey, I'm looking for this, right? And you might even just say something like, I know that tangent is sine over cosine, and I know that secant is 1 over cosine. And in general, we don't work both sides at the same time, but you might write that just to keep in mind what you're looking for, or what you're trying to turn this into. And that may have helped in terms of having some vision of where you're going with these. Okay. Example number 2. It says prove or verify the identity. Same thing as show that. Instructions will vary between those. So let's see, on the left we have cos theta over 1 minus sine theta, and a secant theta, and a tangent theta. Okay, so this step right here, this is going to be kind of new, but you have seen this in a couple applications. We've had stuff like, if you have this, like 1 minus x, where you multiply by, and a lot of the times it's called conjugate, so 1 plus, oops, that's not a square root of x. Alright, where we change the sign and we multiply both top and bottom by it. So by multiplying, this is just an example, okay, of something that you have seen in the past. So if we had something like this and we were trying to simplify, we change the sign of the last term and we multiply top and bottom by it, right? So this doesn't actually change the value, it's 1. And then after foiling and distributing, we end up with something that is simpler and cancels out. Okay, so we have seen this, and we're using some variation of that for this. This is kind of a trick that pops up in math as helpful very frequently. So we have 1 minus sine theta, so we're going to multiply top and bottom by 1 plus sine theta. And we just pulled that out of nowhere, hoping that it will work. And that's sometimes what we do with these. So after distributing and distributing, we got cos theta plus cos times sine. And then down below, after foiling, alright, these cancel, because it's going to be a minus sine theta plus sine theta. And we're left with 1 times 1. And minus sine squared theta, which, from the previous question, right, our Pythagorean sine squared plus cosine squared equals 1, most common identity, we know that this is cosine squared of theta. So I think that's what happened in the next step. Whoa, easy there. So this stays the same. Turn that into cosine theta, and then I think I'm going to split this up into 2 fractions. So this over this minus this over this. Let's see. Oh yeah. So we have cos theta over cos squared theta, right? This cancels with one of these, leaving us with 1 over cosine theta. And we have one of these canceling with one of these. Let's see where that leads us. Follow the arrow. Ah yes. So this looks better, simpler. 1 over cos theta, which we know as secant theta, minus sine theta over cosine theta, which we know is tan theta, and holy moly, that's what we were trying to show. So, pat ourselves on the back, write a big smiley face, and rejoice. We did it. Yay. So, in going through these, you may be watching this and thinking about this and being like, I have no idea how he knew to do that. Truth be told, neither did I, alright? When I was a kid, I used to, as a kid, computers basically didn't exist. So we did stuff like this, a maze, and you start and finish, and you don't look at the maze, and I think you know what this thing is, right? Hopefully. But I was totally into these, and I didn't look at these. Aha! That's the answer. I looked at it and I thought, well, let's try. And I'd go like this. I'm trying to get to the finish. And I'd go, oh, shucks. And so I'd try something different. And, well, let's go down here. And, all right, this looks promising. Uh-oh, I'm going the wrong way. Well, oh, fiddlesticks. And then I would, okay, you get the point, right? But I had to try a lot of different things until I actually found the correct way and got to the finish. And think of this. Here's your brain thinking about this. Think about this as you're going through these, okay? You may try several different routes that don't work, okay? It's nearly impossible, unless you've been doing these for 20 years, to just look at the maze and say, oh, I see how it's going to go, okay? So it may be hard to do, but that's the reality. All right, a couple questions from homework, hint, hint. Simplify. So again, simplify, we're not showing that one side is equal to the other. We're just reducing it. And if you look at the notes from part 1 at the bottom, one of the hints was to turn it into, or write in terms of sine and cosine. So we know cotangent is cos over sine. Cosecant, is 1 over sine. So let's rearrange this, rewrite it just in terms of cosine and sine. So here's cotangent, and here's cosecant, and here's the sine. So now we have our expression. It's all in terms of sine and cosine. Now let's try to simplify. So I see this and I think, okay, it's probably that common denominator. And in which case, the common denominator would be sine of theta, so we're going to have to multiply by sine theta and multiply the top by sine theta. That's a little messy, sorry, but it ends up looking like this. So down below we got this, sine squared theta over 1, and alright, so if we're combining these two, right, here's our common denominator. Notice how up top we're going to end up with 1 minus sine squared theta. How often does this turn up? So often. Yes, that is the Pythagorean identity, and hopefully you're familiar with that and you recognize hey, that's the same thing as cosine squared of theta. So let's do that as our next step. Totally. Wait, oh, there we are, right? We got our common denominator, and then we're recognizing that this right here is equal to cosine squared of theta, giving us this, and now you're like, wait, but that looks too crazy. No way. We have a fraction being divided by a fraction, so it's multiplying by the reciprocal. So this is going to go up here, and this is going to go down here. Dividing by a fraction, same as multiplying by the reciprocal, and it looks like that. Okay? Now you're like, oh, thank goodness, we get to cancel some stuff. Right, and we're left with 1 over cosine of theta, which is equal to secant theta. So here is our simplified form of that expression. And I know I was going through that kind of quickly, so maybe I'll just pan out here. And you may copy that down. Maybe you paused in the middle. Okay, so that's simplifying that. And last but not least, let's take a look at this. So verify. Same thing as prove or show that. So what I see over here is FOIL. And have you noticed that in basically every one of these FOILs, the inners and outers cancel? Oh, I actually wrote it out here for us. Inners, outers cancel. Oh, and also notice that I chose to work with this side. How did I know that? Well, I'm a math teacher, but you could try rearranging this, but this is going to be, because there's so many pieces, it's easy, and you see, hey, I could FOIL, this would be a good place to start. So we kind of leave this alone, and we start with one side. So we cancel these, and I'm hoping by this point you recognize, hey, that looks like that Pythagorean identity again. It's just all over the place. And you know that this is now equal to sine squared of theta. This is cool. So we have sine squared of theta. Oh, but then we look at the right-hand side, 1 over cosecant squared. Wait, I know that 1 over cosecant is sine. So this is from the reciprocal identities on your notes page, part 1. And so as the last step, we could say, hey, this is equal to, and I actually did rearrange this side as the last step. So we got sine squared theta equals sine squared theta. We have proven it. Pat yourself on the back, give yourself a smiley face, however it goes. Alright, so that's it for these 4 examples. Don't forget that whole maze concept, right? You just have to kind of try stuff. Have a lot of scratch paper, you work in pencil, whatever it takes, but you can do it.